So welcome along to the Science Sketchbook video on physical changes and chemical changes. So we're talking about changes in states of matter. So I'm in the middle of drawing a nice big blue box all the way around both of these different categories of changes. Reason being, when a chemical change occurs, there will also be a physical change, which is why the red box is inside the blue box. Now, just remember that, don't worry about it too much, and we'll come back to it at the end of the video, and hopefully all will become clear. So, examples are always useful to help get our heads around what's actually happening. So, a really simple one first. If you have a very hot day and you want to cool down your drink, you may put an ice cube in it. So, this ice cube is a solid. If we add heat energy from the scorching hot sun on a lovely hot day, that ice cube will melt into your drink and hopefully cool it down. So it's a useful physical change. So, ice plus heat equals your glass of cool down drink, whatever you choose to drink. Okay, so very simple. However, if you put that in the freezer, that water, it will turn back into ice. Water in liquid form, water in solid form. Obvious, I know, but this will be important later because water is good old H2O and water is the same chemical composition over here. You get what we're talking about, not a chemical change. The chemicals composition are equal throughout. So, another example. If you had, say, a great big tasty bar of chocolate, for example, which I won't spend too much time drawing, and you got a hammer, and you simply went a bit crazy and smashed up your chocolate. This would cause a physical change in the chocolate. You would end up with a pile of broken chocolate equals smashed up chocolate all over the place. Which you might want to do if you were making a cake out of chocolate, and smashing it up would increase the surface area of it and would help it melt. So it's physically different. You can see the difference, which is always a help with a physical change. So the chemical composition of chocolate, I don't know what the chemical formula is, but it will be the same both ends of the change. Now, if you melted that down and put it back in a mold, you could come back to the original. So, physical changes you can often undo. However, it is more difficult to undo chemical changes. So, an example of a chemical change would be if we took a nail, an iron nail, nice and shiny and bright, and then if you left it outside and you left it out in the open, in the air, you would end up with a very sad looking, rusted, broken apart, the head might have fallen, given up a ghost, nail, rust. Chemically, this is iron plus the oxygen in the air equals rust, which is Fe2O3. So, it is very difficult to turn rust back into a nail. Some chemical changes can be undone, but generally, as a general rule, to help you work out whether you're looking at a chemical change or a physical change, they usually can't be undone. So another classic example is if you took a log of nicely seasoned timber, which might have been kiln dried, or it might be air dried, but there's not much moisture in it, so it burns nicely, and you set that log on fire. Not a very good fire, but you get the general idea. So, and you end up afterwards with ash broken down. The combustion here is causing a chemical change. The oxidization here is causing a chemical change, but it is also causing a physical change. This is where we come back to the beginning of the video, where we drew a nice big blue box all the way around, including the chemical changes. And like I said before, you can see the difference in a physical change. It looks different. You can see the difference here as well. The state of matter has changed. But here in the red box, a chemical change has happened. There is a difference between what you put in and what you get out. Technically speaking, what your reactants are and what your product is. It's a different product. However, over here, water is water is water, because you've only put it through a physical change and not a chemical change. There are obviously many more examples, but these are just a few to get your head around the basic differences between physical changes and chemical changes.